This video will cover capital budgeting and net present value. Let's discuss capital budgeting first. Make sure we're on the same footing here. Capital budgeting is all about the process of analyzing various projects. And what I mean by projects, it could be a new product line, it could be some new software, it could be a manufacturing plant, some component of your business, and you're thinking of investing in it, you're considering it, you're proposing investing in some type of project. So you estimate cash flows associated with it, you estimate risk, and then you evaluate it. Is this a good project to invest in, given its risk and return? And then you assemble a list of projects and how much they cost, and that's your capital budget. So you're budgeting capital, money, to invest in property, plant, and equipment, product lines, and so on. That's capital budgeting. Net present value is a technique, and it's a technique you're kind of familiar with already. And that technique will help evaluate whether or not to accept or reject a project. So there's a proposal on the table about project A. Is it worth considering? Is it worth investing in? You need to look at the risk and return. That's where net present value comes in. This is the first video of several on capital budgeting. There are various rules or techniques or criteria to evaluate projects. Rules, techniques, or criteria. That's the terms often used to evaluate whether or not a project is acceptable or not. Net present value is one, so we have NPV. There's also a concept called internal rate of return, IRR, which we'll cover in another video, and its cousin called modified internal rate of return. That's two types of additional techniques or criteria or rules. Then there's payback method, and then there's discounted payback. These all have different ways of evaluating whether or not a project is acceptable. What's really cool about net present value, as you'll see in a minute, is you end up with a dollar amount to determine whether or not a project is acceptable. When you look at internal rate of return and modified internal rate of return, it's an interest rate, a percent. And then when you look at payback and discounted payback, the solution that you get, the criteria, happens to be measured in years. So we got three different rules, sets of rules or criteria here. One's measured in dollars, one's measured in returns, which are percent, and the other is measured in years. So we'll have a video separate on net present value, this video. Then we'll have a video on internal rate of return and modified internal rate of return, and we'll have a separate video on payback and discounted payback. And then we'll tie it all together and summarize and compare and contrast all these methods to see which is the best method and and what are their pros and cons. Okay, so now let's talk about NPV. And like I said before, you pretty much have seen this before. This should be relatively nothing new. Net present value, the formula looks like this. NPV, net present value, is cash flow at time zero plus the present value of cash flows in the future for however long they go out. And so the term net here, N, net present value, means, look, you're taking the present value of all future cash flows, and the net part comes that this is the cash flow at time zero. This is the money you're spending to invest in the project. This is negative. So it'll be a negative amount. It's the amount you invest in so that you get this cash flow, and all future cash flows. So as you can see, it makes sense. That's called net present value. We've been dealing mostly with present value. Now we're going to net it against the cost. So this is the cost of the project. Now, let's look at two different projects here. And the way to draw this out is with a timeline. So we're going to have two projects. Let's look at the first one. 4 periods long. We're going to call this Project S. And the reason we're calling this Project S is that the cash flows come sooner rather than later. And what I mean by that is most of the cash flows are coming up in period 1 here and period 2 relative to the other periods. So this is cash flow that comes sooner rather than later. In some textbooks, and our textbook may refer to it as this is the shorter term project, in the sense that the cash flows are all up, not all, but mostly up front. And we're going to have a cost here of 1,000. So I've organized it nicely that the positive cash flows are up top above the line and the cost is below the line there of 1,000. And we're going to have a 7% discount rate associated with it because, hey, we're calculating present value. If we're calculating present value, we need an interest rate to discount things back on. We'll call it that 7%. Now, what you could do, and you have all the tools to do it, is to literally calculate the present value of each one of these cash flows, right? And I'll do it for this last one, 100 divided by 1.07 to the 1, 2, 3, 4 power, right? And that would be the cash flow, the present value of this $100. You do that for each one, add it all up, including netting out the $1,000, and what you would get would be a net present value of $80.27. That's the net present value. So first off, like I said earlier, look, that's in dollars. So what's really cool about net present value here is that it's measured in dollars and it directly adds the shareholders' wealth. So if we go back to the beginning of the course, we talked about shareholders' wealth and adding the shareholders' wealth because shareholders own the company. Well, this is consistent. Adopting this project is consistent with that idea. Now, before we go further, let's keep in mind what these cash flows represent and what they don't represent. These cash flows here that we're looking at represent all of the revenue and all of the expenses associated with this Project S, except for financing costs. Financing costs come into play with the 7% discount rate that's used to calculate the present value, the net present value. And so you need to keep that in mind. We saw that in an earlier chapter, and I'm just reiterating it. This is all the expenses and revenue here, except for financing costs. Financing costs get built into the problem through discounting. And not only that, but this 7% not only reflects the opportunity cost of money, it also reflects risk. So the higher the risk, the higher the R, the discount rate that we use here. And if R goes up, the present value of each cash flow goes down, then that means net present value goes down. So it's a direct application of present value calculations that we did at the very beginning of the semester. Now, what we want to do for convenience purposes and looking ahead for other videos where we look at internal rate of return, we should be able to put this into our calculator. And we're going to use a specific row of buttons on your calculator to do these calculations. And the row we're going to look at starts off with a second button on the BA2 Plus, the Texas Instruments calculator. And then it's going to have a CF button. Well, that looks familiar. It's cash flow. And then there's a button called NPV, and that looks even more familiar. And then we have IRR, which I mentioned up above here, that in another video, the next video, in fact, we're going to compute internal rate of return. So we'll be using that button. We'll be using this button shortly, but not in this video. And then the next button that you see on this row is a arrow button to the left. We don't need this. We're going to focus in on these buttons here. So let's get this problem into our calculator. And we're going to hit, first off, put this in blue, we're going to hit the CF button, this guy right here. Hit this button, and what's going to pop up is it's going to say CF0. And that means what is the very first cash flow at time 0? And that's negative 1,000. You're going to hit enter and then the down arrow. You hit enter and the down arrow, and you're going to see it on your display, CO1. The 1 stands for cash flow in period 1. And CO1, you're going to want to put in, come up here, the $800, this guy right here. 800, enter, and then down arrow. And then when you get to the down arrow, you're going to see a display that says FO1. That means the frequency of the first cash flow. I should be a little more precise. The cash flow in period 1. We're always going to keep that 1. In fact, that's the default. That's what should already be in your calculator. So if it's already there, you can just hit the down arrow and slide past it. If not, put a 1 in and enter with a down arrow. So go past this FO1, and when you do that, you'll come to CO2. That's cash flow for the second period, and that's going to be 200. And you go to enter it and hit the down arrow, and then you go to see the frequency for cash flow 2. Leave it at 1, move down, and again, if it's not 1, hit 1, enter 1 in the down arrow so it sticks and gets in there. Now, when you hit this down arrow, you're going to get CO3, and you're going to enter 100. And the down arrow. And then you're going to get FO3, and that's going to be 1. And then you're going to see on your display CO4, and you're going to plug in 100, hit enter, down arrow. And at this point, it basically stops because there's only 4 cash flows and we've put them all in the calculator. But what you want to do is peek ahead. Check to see, by using your down arrow, check to see, well, first you should make sure that FO4 is equal to 1. But peek ahead to see if CO5 equals 0. Here's the thing. You want to make sure CO5, CO6, and all the future cash flows are 0 because they are effectively 0. We just didn't put them here. My point being is if you had a problem with maybe 7 or 8 cash flows from a previous problem that you may have been working on, what's going to happen is you're going to have those leftover cash flows from the previous problem, and it's going to be there. You need to get rid of it. It's going to be there carried over from the previous project. So make sure you get rid of them by peeking ahead. So now, when you've made sure that all those previous cash flows, all those CO5s and CO6 are 0, peeking ahead, now what you want to do is you want to hit NPV. And when you hit NPV, what'll pop up on your screen is an I. It's asking you for the interest rate. So when you see the I, plug in 7, hit enter, and the down arrow. And what you'll see on the display after that is NPV. And when you see NPV, hit compute in your upper left hand corner. And when you hit compute, out will pop $80.27. And that is your net present value. That is one project. Let's look at another project similar to this one. And the project here is going to be project L. And L is going to mean cash flow comes later. And 1, 2, 3, 4 periods, and the cash flows will be in this project 50, 100, 500, and then 800. And the discount rate will be 7%. The cost will be $1,000. Now, with this information, again, you could calculate the net present value by hand, well, with a calculator, but working it all out, or you can put it in and into your cash flow mode that I just showed you. If you do that, either way, you should get the same number, and you'll get an NPV equal to $152.54. So NPV for Project S was $80.27, and NPV for Project L is $152.54. And so we ask, well, out of these projects, which is the better project? Well, right off the bat, you'd say, well, it looks like this project is best because it has the highest net present value and it adds $152 to net wealth to shareholders, versus the short project, S, only adds $80. Well, that makes sense, but we need to be careful about the type of projects and the situation we're in before we come to a conclusion. And here's what I mean. There are two situations that we need to take into consideration before we make a decision on which is the better project using net present value. There's the idea that you have projects that are mutually exclusive, and then you have projects that are independent. Mutually exclusive projects means one or the other. The classic example would be, do you want to use a forklift in a warehouse or a conveyor belt system? It's either one or the other, but not both. If you have a plot of land on a corner somewhere of a street, do you want to put a restaurant there or a laundromat there? You can only put one in, so it's one or the other. And so when you have mutually exclusive projects and you have one or the other is the possibility, you pick the one with the highest net present value. Assuming, of course, the NPV is positive. Now, if you have projects that are independent, the classic examples would be, Dunkin' Donuts, if it's going to open up a store in Washington, D.C. versus Los Angeles, well, there's not going to be any correlation or connection to the cash flows in D.C. versus L.A. So those projects are independent. The same thing if you're opening up a Walmart in Oregon versus Texas. They're going to be independent of each other. If you open them up next door to each other, two stores next to each other, obviously they're going to feed off each other. And that's going to be a problem. The sales of one store will be dependent on the other. The cash flows will be dependent. So if the projects are independent, then we can accept both projects if they're profitable. So if the NPVs are greater than zero, we can accept both projects. So if we're in this situation and Project S is in Oregon and Project L is in Florida, well, we can accept both of them, provided we have enough money to be able to pay for them. And keep in mind, we're only going to consider positive NPV projects because they add to shareholder wealth. If you have a negative NPV, well, that means it detracts from shareholder wealth. You might as well not even do the project. Why lose money? If you have a zero NPV, well, you're kind of indifferent as to whether or not you want to accept the project. You might want to go back and reevaluate truly whether or not you got the right numbers and other criteria that may be non-quantitative before you decide on the project. Now, once you calculate NPV, ask yourself, are these projects mutually exclusive? It means one or the other. You pick the net present value that's highest. And then two, if the projects are independent, which means you can accept all of them or reject all of them if they're negative net present values. If they're independent, then you select all projects that have a positive NPV. And so that's how the rule works. And keep in mind that I'm going to use these two examples in future videos when I do internal rate of return and modified internal rate of return and payback. Now, let me conclude this video by saying net present value rules the rules. And what I mean by that is net present value is considered to be the best rule out of all those that I listed above, the best criteria against net present value, against internal rate of return, modified internal rate of return, payback, and discounted payback. Net present value rules the rules for a couple of reasons. One, it's measured in dollars, and that's consistent with shareholders' wealth that we talked about at the very beginning of the course. 2, it considers the cost of the project and all of the cash flows, not some of them, all of the cash flows were considered. And 3, we also considered the opportunity cost of money and risk in the analysis. So we have everything that we need to consider with net present value, and it's measured in dollars.